How is mass flow rate used in the steady flow energy equation? Imagine watching water flow through a river, constantly moving without stopping. Now, think about how much water passes a point each second. That's similar to what mass flow rate measures in thermodynamics. When engineers analyze systems like turbines, heat exchangers, or compressors, they need to know how much fluid is moving through the system over time. This is where the concept of mass flow rate becomes essential. Mass flow rate is the amount of mass passing through a specific point in a system each second. It's usually measured in kilograms per second. Unlike volumetric flow rate, which measures how much space the fluid occupies per second, mass flow rate considers the fluid's density. So, if the fluid is denser, more mass passes through in the same amount of time. In the steady flow energy equation, the mass flow rate acts as a key link between the fluid's energy and the total energy transfer. The equation itself is a way to balance energy entering and leaving a control volume, which is a defined space where fluid flows in and out. The equation accounts for energy carried by the fluid, heat added, work done, and changes within the control volume. Here is where the mass flow rate plays a vital role. It multiplies the specific energy of the fluid, like internal energy, kinetic energy, or potential energy, to give the total energy flow rate. Think of it as turning the energy per unit mass into the total energy moving through the system each second. This helps engineers figure out how much energy is being transferred with the flowing fluid. For example, if you know the mass flow rate and the fluid's properties, you can determine how much energy is entering or leaving a system. If the mass flow rate increases, the total energy transfer rate also increases, assuming other factors stay the same. This directly impacts how well a device performs, whether it's generating power or transferring heat. Since the mass flow rate remains constant in steady flow, it ensures that the energy calculations stay consistent over time. This constancy makes it easier to analyze and design systems, because you know the amount of fluid and energy moving through the system doesn't suddenly change. In summary, the mass flow rate is used in the steady flow energy equation to measure how much energy is carried by the moving fluid. It connects the physical movement of the fluid to the energy transfer, allowing engineers to understand and optimize thermodynamic devices effectively.